Alright everybody, welcome to another video from MrLaserGuy.com. Anyway, don't know how the audio is going to come out on this because I forgot my lavalier mic and audio recorder, and I didn't bring it out into my trailer here. So I'm using the audio on the webcam, which is an old webcam. And so there again, apologize for that. I'll eventually get a better recording setup, but I need to use a webcam or something like that if I want you to be able to see me and also the screen at the same time. So anyway, enough with all of that, and let's go on to what we're doing here. What I needed to do was I had purchased a Harbor Freight inline fan. And I'll try to throw a little picture of that up. So anyway, what I needed to do, that's an 8-inch fan that I needed, and the laser here is a 6-inch exhaust, and I have a 6-inch exhaust in the roof. So we have an exhaust fan going up through the roof, and an exhaust fan currently that's built into the laser, and exhaust duct going up and attaching to one of the exhaust ports in the roof. And that's sort of okay. It does exhaust, but it doesn't do that good of a job. So what we're going to do here is I had to make adapters. I looked at I could go just buy some, but they're like $10 a piece. You need them for both ends. So that's at least $20 there. And I said, hey, I got a 3D printer, so I'll see what I can make. Now, I usually do use Tinkercad because it's real easy to use, and I use that. But Tinkercad has a problem with cylindrical or round objects. It really makes them jagged around there. It's not very smooth in its ability to create round objects. Okay, so I needed to make a reducer that would go from 8-inch to 6-inch. So I wanted it to fit inside the 8-inch opening of the fan, and then fit inside the 6-inch of the duct. So what I did, this is on the screen here that you can see here. This is the reducer that I came up with. Now, this is about a 15 to 16 hour print, and it uses quite a bit of filament on the 3D printer. So I don't want to print the whole thing out without testing. So what I did when I initially just started designing this is I printed a ring of the bottom piece here and tested it and see if it would fit inside the fan, and it fit perfect in there. So then I went ahead and designed this, and I did it in Onshape because Onshape does a whole lot better with round objects. And so I had to do a lot of little learning here because I'm not that familiar with Onshape. And I was eventually able to create this, and I'm going to try to rotate this around a little bit here. So you can see that this is like a reducer, and it goes from the width that would fit inside the fan to the width that would fit inside the exhaust ductwork, the round ductwork, and it's hollowed out, and they call that a shell in here. Now, there's one thing I did not learn how to do in here, and I didn't want to take the time, is the bottom is still solid. So you basically got a nice little boss here that I guess if you wanted to use it for a vase, there you go. Perfect little vase there. It's basically a 6-inch at the top and an 8-inch at the bottom, and reduces down in the curvature here. So anyway, we basically ran that through there, and I got that and I separated it down. But like I said, it does have a bottom in it. And so what I had figured out is I had specified that I wanted the shell to leave 1/8 of an inch. And let's zoom in on this. So I wanted to leave 1/8 of an inch across here. And so that's apparently what it's also done at the bottom, is it's left 1/8 of an inch. And then I also put a bevel on the top so that it would be easier for me to slip the 6-inch ductwork in. So hang on a minute. This is the duct that came with the 3D printer, with the laser, and so it's got the collars and everything else. This was too short to go up from the laser to the roof, and so I bought a 8-foot piece off of Amazon, which surprisingly enough was cheaper than buying a piece of the 8-inch flex or 6-inch flex duct from Home Depot or Lowe's. So I got it off of Amazon. And it reaches all the way from the laser to the roof, and that's what I've been using. So anyway, like I said, initially I took this. I'm going to bring this over, try to anyway. It's very heavy. A very heavy fan. We're going to try to get this up here, and hopefully we will do it. Alright, so this is the ring, test ring. This is the test ring that I printed. It's basically about maybe a 1/2 inch tall, thereabouts, and it was designed to go, it fits right inside. And if I go at an angle, it's a little snug, but if I go straight in, it fits perfectly in there. So right now it's just sitting on the other brackets. But eventually I will remove those, or I could spin them around and actually use them to clamp this in. And so I'm going to look at either way that I can do this. I can use the clamps that held the face ring in, or held this guard in. And so I could use that, or I could slide in and actually drill through and put nuts, captain nuts on the inside. But like I said, so I did a test. So that's what I got printing on the printer right now over there, is I have a test of the 6-inch side. So we're going to test the 6-inch side, and we're going to see if it fits inside that duct. And why do I do these tests? These tests took about an hour a piece that they're doing. So the reason is I'd rather waste 2 hours and a little bit of filament to check the fit, like I said, and make sure everything fit, than I would to spend 15, 16 hours and a lot of filament to find out that the darn thing didn't fit to what I was designing. So we're checking the outsides of each of them to fit in here, the 8-inch, and then the one for the 6 is printing right now. And I'll be testing on the ductwork. So we'll be testing that here whenever it gets through printing. So let me put this back over here out of the way. One thing I wanted to, I want to say real quick, I had taken the grills apart, and one thing I did notice on this is not a plastic piece of junk. This thing is well built. It is built to last. About the only thing that can go wrong with this thing is be the motor or the capacitor in there, and I doubt that because it looks like it's very well built. This is cast aluminum or something. This is not a plastic blade. So I know when I turned it on, it did have a little bit of vibration and stuff, but because it's not a plastic blade, that means if I really wanted to, I could pull it out of here and put it on the balancer and figure out where it is and just start taking little drill spots out of the vanes until I got it to balance, and I could smooth this thing right up. So anyway, it depends on how bad it is, but it doesn't seem to be that bad. So anyway, we've got that done there. Now, what we're going to do here is, like I said, when I made this, it chilled out, and it still left the bottom on it. So, let's go here. This is it in Cura. And there again, if I look at it, there's the bottom. Well, this straight piece down here, this little edge here, I had designed that. It's about 1.5 inches tall. And I don't really need that much down in there. So, what I can do is I can select this, and then what I'm going to basically do is do the positioning right here. Now, without actually going over there and thinking and all that stuff, 1/8 of an inch is approximately about 6 millimeters thereabout. So if I come over here at the Z-axis or the Z-axis settings of Cura, and I do a minus 6.5, what that does is it drops, as you've seen that drop that model through the bed on Cura. So it's saying that part of the design is below the surface plane of the printer. Now I'm using a Anycubic Curon. So, but like I said, this is 8 inches around 6 inches, and it's, let's see, 200 millimeters tall. So that's going to be around 8 inches tall, thereabouts. I could have made it shorter, but there again, looking at I want a smooth transition between it, and I didn't want this angle between this and this, because you're looking at a 2-inch difference, so it's about 1 inch in on each side. I didn't want that to be so far that I had to use supports, and so this is well within a very nice angle that it can print this with 0 supports at all. But anyway, back to what we did here. We took the position, we dropped it to a minus 6.5 on the Z-axis, and that put it below the plane. So now we have a hollow reducer all the way through, and this is what we will print. Now, this file will be available to anybody that wants it on my website. I'm not going to upload it to Thingiverse right now. I may later, but this is going to be available on the website for download for anybody that wants it. And so once we get all this done, we will start doing videos on all the other little stuff that we're going in here with the Air Assist, the kits that I'm going to be putting together, and I'm going to be putting together kits that are include just the wiring and wiring harnesses, so that you don't have to do that. And I'm going to have more complex kits that are going to be available where you can do quite a bit of little stuff here. So stay tuned for that. I'm waiting on some parts to come in. I'm going to be building this and then videoing and demoing it on my laser, and I'll show you what you would be getting if you purchase one of my Air Assist kits or my exhaust delay kits. and so we're going to go through that. Okay, everybody kind of knows what an air assist kit is, but there's going to be multiple versions of that. There's multiple ways that you can do it, and so we'll be doing videos on that in the future. So anyway, this is the first step. Basically, you have to get a reducer, and I'd rather spend 30 hours is what it would take to print 2 of these to then go down and spend $10 a piece for it. That of sheet metal that still wouldn't fit right. Yeah. So, I mean, it may fit right on the duct side, but it probably would not fit right at all on the side that needed to attach to the fan. And so my train of thought is I'm going to put that, slide that in the fan, clamp it down or bolt it down, and then I'm going to silicone the lip around. I don't really want to use the silver tape. I will if I have to, but I really don't want to on that end of it. You know what I'm saying? So, anyway, stay tuned. And thanks for watching. Please subscribe, hit the little bell, and that way you'll be notified when I put new videos up. And you can follow me along in this journey, and you can learn everything you need to know, and you get all the support videos on my air assist kit and my exhaust fan delay run kit and the air delay run and all of this. I mean, there's a tons of stuff. You know, I got years and years and years and years and decades and whatever, decades and decades of experience in electrical controls and design and stuff. So, you know, the way I look at it, if I could design controls for a 300 something foot heat treat facility of it, and the controls for all of the conveyors, off-road kits, millimeter nails, everything else that needed to go through that, I could sure design controls for a Chinese laser. See you in the next one, and enjoy talking with you. Thanks.